Yeah. Hi, so welcome to the talk. Today I'm going to be talking about systematic evaluation of neural retrieval models on the Touché 2020 argument retrieval subset of BEIR. So this was a work done in collaboration with the original Touché 2020 authors, which are from the University of Jena, along with Unicam and University of Kassel. So, very interesting. So, probably many of you know already the BEIR benchmark, or at least you would have heard the MTB benchmark, which are pretty recent benchmarks being used to evaluate different sort of neural retrieval models which are there currently present. And many of the times, what people really care is the end metric and the end score. And if you would have seen probably the leaderboard which has been taken from the MTB paper, so these days people just look at what is the best performance on this particular leaderboard, and based upon the score they tend to choose that as their model. So on the left, what we did was the BEIR benchmark, we sort of have a plot where we plot different models. Here we have a baseline, a round one, which is highlighted in gray. And we also have evaluated different other models, such as fast retrieval models or dense models and other multi-vector models. So there were a few curious things, like when initially we worked with the BEIR benchmark and following up with work, is that if you see one of them, like more specifically the Touché 2020 dataset, so you can see all the different systems are actually underperforming BM25, and still up to date, BM25 kind of outperforms a majority of the existing neural retrieval models, be it dense, sparse, or multi-vectors. So this is sort of the research motivation in our paper, which we wanted to look at, was like what is going on, and actually not just looking at the final score, the NDCG at 10, but actually in depth examining both the data set and as well as the model. Nice. So yeah, before we start with that, so we have, let's talk a bit about the Touché 2020 dataset. So originally, it was introduced in Bondarenko et al. 2020. And in Touché 2020, we have an argument which is modeled as either a conclusion, which contains a title, which is often a claim which can be accepted or rejected, and a set of supporting or attacking premises. So Touché evaluates the argument retrieval task, so which has debate titles as often argumentative queries. So for example, in our case, we have whether should government allow illegal immigrants to become citizens. And you would often then search using a retrieval model, and yeah. Yeah, I can probably speak about it. So yeah, you have basically a query, and you will have some sort of arguments which consist of the debate titles, which are possibly there as the document, which is highlighted in bold, and you have the body, which contains either a premise, so which is either in support or in attack of that particular debate title. So we wanted to understand, like I mentioned, why sort of neural retrieval models were underperforming BM25 on Touché 2020. And the moment we started to approach the problem, we didn't know what to do. So should we, how to do the analysis? Should we evaluate the data sets? Should we look at the models? What should we do? So there were many things which we wanted to try. In the paper, what we ended up doing was we conducted a whole systematic evaluation or a reproduction study. So our reproduction study has been broken into 3 parts. So the first part is more model-centric, where we sort of re-evaluate the models on Touché, we reproduce the results, and we see what kind of results we are, or where the models are lacking. The second part of it is more dataset-centric, so we actually looked into the intrinsic characteristics of the Touché 2020 dataset. And the third one is more theory-centric, where we actually try to see if we can justify our findings theoretically using IR axioms. So talking about the first part, where we did a black box evaluation, so this is one of the graphs which I really like in the paper. What we do find in Touché is that, very interestingly, so what I plot is on the y-axis, I plot the average document length which is being retrieved in the top 10 documents. retrieved by all the neural models, and Oracle is basically the QRELs, or the relevance judgments, and what's sort of the average document length there. So we find a very sort of a short document bias in the neural retrieval models. So as you can see in the sort of this box plot, on the top, BM25 is the model which actually retrieves much longer documents on average. Whereas the more and more you try to evaluate and you check with the neural models, their document lengths on average are much shorter than in comparison to BM25. And what we found is that there is like a Spearman rank correlation of like 1. So that means that on average, if you have a shorter document, so on average you are performing worse on Touché. So we found there was a perfect correlation with that. Next, since we saw this actually with numbers, we actually wanted to go ourselves and look at the results of the models and what sort of documents they were being retrieved. So we found a very interesting observation that retrieved documents, often you would have a very high lexical overlap with the title, but it would often contain a very noisy argument premise. So in this case, like for example, we have the query whether should social security be privatized or not. And as you can see on the left-hand side, the more relevant documents, which has been highlighted in green. So in this case, you can see that BM25 and actually Citadel Plus, which is a multi-vector approach similar to Colbert V2, is able to retrieve the good document. But the more part which was more surprising is that if you see the topmost ranked document of something like Slate V2, Dragon Plus, and in general some other few models, you can actually see that it retrieves arguments such as like social security, RIB should be privatized, pass. And this was actually what we found in a lot of the top documents in Touché. Now, since we got some empirical results, we wanted to quantify actually this error, like how many top 10 of the documents they are not relevant, and as well as they are shorter than 20 words. So if you see these error rates, they're actually pretty low for BM25, almost less than 1%. But the more and more I was evaluating the different retrieval models, actually it can go up to like 50% also for TASP. So this is pretty insightful with the error rates. So that was the part with the model evaluations and in general black box evaluations. The second part of it is we are trying to do more intrinsic characteristics of the data set. So we are evaluating, or we're taking a deep dive within the data set itself. So Touché, if you see, which is on the rightmost, which is the green one, so it has a different document length distribution actually of documents present within the corpus. So if you check, usually, welcome back. So if you look at the intrinsic characteristics of the Touché dataset, so you can find that in comparison to MS Marco and Hotpot QA, like the document lengths we plot for the whole collection, Touché has a very huge spike of very short documents. And it also has a longer tail of much longer documents. So on the x-axis, it's basically the number of words on average. And this is what we found is like the document length distribution is much different from other IR datasets which are commonly present in BEIR benchmark. Also, another thing which we observed was like many of the models, neural models in which we are currently being evaluated, so a majority of them have holes. So for example, they would actually retrieve documents which were not originally seen by the annotator. And including BM25, it can go like up to like 77% for even like TASP. So in order to sort of alleviate the situation, like this issue, and also to ensure a more fair evaluation, because we actually wanted to see if we remove the short document bias, how does it still like, do still neural models can outperform BM25 or not? So that's sort of the question which we want to ask. And for these things, we actually do two sort of things. The first is denoising. So we remove the conclusion, which we found to be sort of confusing the models. And we also sort of remove very short documents, which are less than 20 words, which we experimentally determined in our paper, and actually clean the noise which is present within the corpus. Also, second, what we do is we do post hoc judgments. So we actually fill up the whole at 10 across all the tested models, and we annotate the sort of the unjudged model results. And interesting things we found is that for Touché, since it's argument retrieval, it's often very subjective. So we found that domain experts are really good. Since we had authors from the original dataset collaborating with us, so we in general had we had domain experts for doing the argument relevance task. And so on the left-hand side, you can see we do the denoising, and on the right-hand side is just an illustration of the post hoc judgments. So interestingly, so this just plots the dataset characteristics after denoising and after adding post hoc judgments. So there are two things which are very interesting we found. So first part is if you look at the denoising, so we ended up like removing about 78K or 80K arguments which were present in the original dataset. And since we removed documents, we actually also lose out on the QRELs or the original sum of the documents which were mapped. And out of those, since we removed those documents and the QRELs which we kind of missed, only 12% of those were actually relevant. So a majority of them, like 382, were actually not relevant. And after we added post hoc judgments, so we add about 1,064 additional judgments into the collection, we find that we added like almost probably like 78% of it was actually relevant. So we ended up adding more relevant judgments into the pool or into the data set. Now, coming part to the whole thing or the whole question whether even after doing data denoising and post hoc judgments, how do neural models perform now in comparison to BM25? So in this case, now we find that even after doing all of this, BM25 still outperforms all the dense models and all the sparse models and multi-vector models as well. So in the third part, so as Catherine probably talked about IR axioms, so it's good enough for me not to further explain in the side, but we also wanted to see if we can justify our findings using axioms or not. And historically, axioms have been used to debugging or explaining IR models, and it's also helped to fix some bugs also in IR models. So we covered over 20 different axioms, and I think so in the paper we have 6, 7, but for the presentation, we want to focus on one axiom, which is known as the LNC2 axiom, so which goes into the document length normalization. So as the axiom states, it states that the relevance score of self-concatenation of the document should not actually be lower than the original document's relevance score. So for example, if you have a relevant passage and you're just duplicating it m times, actually the final score of the duplicated version should be equal to the original one because both are relevant. It's just repeated multiple times. And we actually found that BM25 agrees with this LNC2 algorithm or axiom for almost 100%. But on the other hand, the other sort of neural retrieval models, they do not agree to this LNC2 algorithm. So the key takeaways and sort of the future work are these, is definitely I find it's always important to analyze and see the data set where a certain model fails or excels. I feel like metrics such as NDCG at 10 can only give a small point of view of the evaluation, but actually looking at the retrieve results yourselves can give you a better idea of where a model fails and where it excels. We did a systematic analysis which revealed that neural models have a short document retrieval bias, especially we saw this in Touché. And we tried to do a fairer evaluation by actually removing this bias and trying to evaluate, trying to evaluate in a more fair way. So apart from that, we had another takeaway was we did some amendments to actually improve it, but still, BM25 kind of is outperforming the neural retrieval models. And future work can be more about how can we actually improve neural models to be more robust against this short document bias. So what we find is that document land normalization is an interesting concept, and it's something which you can introduce in the retrieval fine-tuning, and also to extend the work to different cross-encoders and even re-anchors on other BEIR datasets. So yeah, thank you, and if you have any questions, feel free to ask.